Hello, we are the team of José Antonio Wong and Germán Montoya Ruiz, and now introducing the Skyscraper Cleanbot, the ultimate solution for efficient and effortless cleaning of high-rise buildings. Are you tired of the time-consuming and risky task of cleaning skyscrapers' windows and facades? Look no further. The Skyscraper Cleanbot is here to revolutionize the way you maintain clean your tall buildings. For our main goals and objectives, we have designing and building a robot capable of cleaning windows of high-rise buildings, ensure the robot is safe and easy to operate, and also ensure the robot is efficient and effective at cleaning windows without leaving streaks or smudges. For our deliverables, we have final design and construction of the robot, testing and validation of the robot performance, user manual and operating instructions for the robot, maintenance and troubleshooting guide for the robot, and training program for robot operators and maintenance personnel. Our project duration must be 25 months, and for our scope we have research and development of the robot's design and functionality, procurement of material and equipment required for the robot's construction and assembly of the robot, testing and validation of the robot performance, and also documentation and training for the robot's operation and maintenance. The estimated budget for our project is $1,000. This includes the cost of materials and equipment, as well as labor and overhead costs. Assumptions. For assumptions, the project team will have access to the required materials and equipment. The project team will have the necessary skills and expertise to design and build the robot, and also will be able to complete the project within the allocated budget and the time frame. Finally, the robot will be able to operate effectively and safely on a different type of buildings. This project faces two significant risks. The first risk involves safety hazards associated with the operation of the robot. Operating a robot at high elevations poses inherent risks, including the potential for accident, injuries, and safety violations. These hazards could lead to project schedule delays, or additionally safety measures and negative impact on our project overall quality and reputation. The second risk relates to technical difficulties during the construction and assembly of the robot. Building a robot capable of effectively cleaning windows on tall buildings is a complex task. Technical challenges may appear, causing delays in the project schedule as troubleshooting and repairs become necessary. Additionally, costs may be incurred during the address these difficulties, such as purchasing extra equipment or materials. Furthermore, if the technical issues are not resolved, the quality of the product may be compromised, affecting its efficiency and performance. The stakeholder matrix helps us to identify and see the level of influence and interest of various stakeholders in the project. Here's an example of our stakeholder matrix. The scope statement outlines the customer requirements for a project. In this case, the project involves developing a system that meets 7 requirements, including sending notifications upon receipt of payment, efficiency, safety, versatility, durability, customer support, and innovation.
Then we have the statement of work. The statement of work is how we're going to work to make our product. For example, the first thing we're going to do is market research and analysis of customer needs, the design specifications and drawings for the robot, the procurement of necessary components, for example, the motors, the sensors and controllers, the assembly and testings of the robot, the development of the user manuals and operation instructions, the production of marketing materials, and the customer support and maintenance services, because we know that at some point the materials will wear out, so we have to do such good maintenance. Then the deliverables that will be produced as part of the project are the design specifications and drawings for the robot, a fully functional and tested window cleaning robot, the user manuals and operation instructions for the robot, the marketing materials and finally the maintenance and repair services for the robot. The acceptance criteria. The points mentioned above all have to be accepted by the client. That is, the client will be informed until the criteria are met, all in order to deliver a product that satisfies everyone equally. But there are some exclusions. For example, the following points are excluded from the scope of the project. We have the window cleaning services performed by humans, the sales and distribution of the robot outside the agreed upon territories, and the modification to the robot after the delivery, unless agreed upon by both parties. The work breakdown structure. Our process to make a robot have mainly 5 parts of the process. The first part is the design area. In this area, we analyze the work area of the robot and we design the robot mechanisms based on the measures we took from the work area. And then we make the robot's plans. The second area is the materials. This is the area where we make a list of the materials we need to make the robot, and then we find the materials and we test them. The third area is the programming area. In this area, we find the software to use. Mainly is the software Micro C Pro, because we use the PIC 18F4550, because that PIC have all the things we need to make a robot. Once we have the software, we make the program, the code in the software. Then we have the assembly area. This is the fourth area. In this area is where we make the robot. We follow the mechanism plans, assemble the electrical part, and then we enter the code to test the prototype. Once the robot is finally good, we pass to the fifth and last area, the delivery area. This is the part of the project where we prepare the final presentation of the product. Then we send the product to the client and we look for a review of our robot to improve and update this robot and have a good relation with our clients, because we think the communication with the client is a key to the success of our product.
For this schedule chart, we outline the various plans for our project along with the individuals responsible for each task and the proposed time frame to finish this project. We name some tasks in this chart, like for example the project number 1, the project meeting, research and requirement analysis, number 2, designing and prototyping, number 3, prototype and testing, adjustment, etc. etc.
Then we have our budget. This is like all the money we're going to use in the process or our project. For example, if you look the work breakdown structure, you could see that all activities that we described there is in the budget. For example, we can see the design area, the material area, the programming area, and here we specify who is the responsible of each activity, or for example the resource that we need for that activity. For example, in the design area we need a PC, and for example in the material area we specify all the materials that we are going to use to make our robot. Finally, we have the total project budget, that is 64,539 pesos. This activity was very important to us because it allowed us to see if there were parts of our process in which money could be saved, being very useful to avoid unnecessary spending. The quality metrics. Our first quality is the drive toughness. For us, it is very important that our units are not fragile, that they can have an acceptable useful life under the indicated work conditions. Then we have the customer satisfaction. It's something that matters a lot to us as a company because they are the ones who really see the performance of the product and how it affects their work environment. But how we're going to measure these two quality metrics? To the measure of the qualities, we have a verification list, and if you see, we have 6 steps to measure the two qualities. The first step is for the drive toughness. The first step is have the corresponding materials. The second step is assemble the robot and test it. Then see if it resists the working conditions. If that is not the case, choose to change the type of materials with which the pieces were assembled. Then pass the security test of authorities, and that is how we're going to measure that quality with the approbation of the authorities, because we need that approbation to be able to sell our product. Then to the customer satisfaction, we have the following 2 steps. The first step was delivered to the client, and a positive sample of the service was obtained. If that isn't the case, immediately attend to that customer and assess the situation. Then ask months later, and a specific 2 months later, and every 2 months if the problem persisted. Then we are going to ask to the customer how satisfied he is, and our goal is to obtain like an 100 points in a scale, the 0 to 100.
Previously, we mentioned 2 risks that we encounter and what will be its effect on our project. Now, with our risks plan, we're going to tell you how to prevent it or fix it. First, for safety hazards, the strategy for mitigating these risks involve implementing comprehensive safety protocols and providing adequate training to all personnel involved in operating the robot. Second one, for technical difficulties, we have also a strategy that involves conducting through research and development prior to construction testing and validating the robot's performance at multiple stages, and maintaining open communication among the project team to address any issues that arise. Do you like clean and efficiency? Call us now and get your Skyscraper Cleanbot now.